Inside this case is my breadboard 6502 computer. Started out as Ben Eater's kit. I was able to put it inside this case that one of my neighbors left on the curb. It used to be a cash register from a Chinese grocery. It has a VGA monitor, a USB keyboard, and I was able to salvage the PC power supply. Let's go ahead and turn it on. I do want to quickly demonstrate the little hardware monitor that's actually running on this machine. So this is a VGA text mode, and I can press enter on my wireless keyboard, and I can type in help and get a bunch of commands, and I can sort of, dump some memory. 9500. Let's see if there's anything interesting there. Yep. So this is just the contents of my ROM that's in there. It does support soft power off, so I can just type in shutdown, and the computer will turn itself off. We can go ahead and look under the hood and take a look at how it actually works. So let me move this keyboard out of the way, and hopefully I can get this off under the hood. And there you go. As you can see, it is all on breadboards inside of there. This is the whole breadboard computer here. And on this side is what's controlling the PC power supply. So what we have is a little breakout for the power supply connector, which gives you 12 volts, 5 volts, and 3.3 volts, as well as a 5 volts that's always on, and some control signals. And that's what this board is for. It's always powered as long as the power supply is plugged in, and it provides the on and off buttons for the power supply. So the button is actually connected here, and then this other wire is control wire from the computer, so it's actually capable of soft power off. Back here we have the bulk of the computer. It's mostly standard sort of Ben Eater design. I do have a programmable logic device to do address translations. I even have the original LCD display still plugged in and connected to the VIA. Up front here is the Raspberry Pi Pico, which is responsible for the VGA display and the USB keyboard. So over here we have some level shifters. This is a bidirectional level shifter for the bus, and a unidirectional level shifter for the control signals. And then the wires coming out over here are going to the VGA breakout connector over here. Got your red, green, and blue, your ground, and your control signals, vertical and horizontal sync. 8 bits of color, so you have 256 colors going to the display. The display currently supports just a text mode, 80 by 25 column text, but it is capable of graphics of the sort of 8-bit style, so you can have tiled graphics on different planes and sprites, but I have not done that yet. This is an OTG adapter for converting that to a regular USB port, and there's just a wireless keyboard and mouse dongle in there. Down here is a second Pico that I've been working on. This one's a Pico W with Wi-Fi, so the idea was to actually make this a bit of an I/O controller that can do Wi-Fi and serial. The reason why I'm showing this now is I actually intend to take the whole thing apart, and the reason why I'm going to be taking it apart is this. So this is a 4 megabit SRAM chip, 512K of RAM, and I want to put this in the computer with RAM banking to give this computer 512K of RAM, and then I can continue working on all the rest of the parts. But I thought now would be a good time to demonstrate the computer in its working form before I end up ripping the whole thing apart.